Hello everyone, and welcome to this brief recording. This is actually an addition to tutorial 4, which we have this week. We are analyzing CIMB, qualitative and quantitative data. Now, this is the quantitative measures today. In the market, we also touch on something called the BA ratio and the VAR. And this is actually a market measures. So it's in the tutorial. I just try to, I already explained it to some tutorials just to make it clear. Maybe we just add this video as I promised. So this is the BA ratio, and the BA ratio stands for the price over the earning, which means how much is the price of the share of the bank in the market and how much they earn per share, which means the net income over the outstanding shares. Now, and this is actually, we wanted the higher, the better. So if you look at this example, you have Bank A and Bank B. Bank A share price today is 10 ringgit, and according to the reported income, the earning per share, which should go to dividends, actually, if they pay 100% dividends, it's $1. And you find Bank B, the price is $8, and they pay the same. So as an investor, why would you decide, or a shareholder, why would you decide to buy Bank A and not Bank B? This is, and sometimes it happens that also the price is higher, and they are giving the same thing historically. You are willing actually to pay 10 ringgit based on this data. So this is BA ratio is 10 to 1, and this ratio is 8 to 1. The logic say just buy Bank B and save 2 ringgit or $2. But actually, you can buy Bank A because you have some expectations. Now, the way to measure that, if you think Bank A is growing in the future in a way that this price be shortly, they have huge potential to be 15, then in this case, actually, you are willing to pay, to ignore the, because this earning will increase. If not increasing in the price, it will increase in the capital gain. And this earning will increase in the future. This is the expectations. And if you expect this price to go to 15, that of course you are willing now to pay more. Also, they are historically giving the same return. And the way we do it, for example, here, the way to measure it, whether this bank actually is exceeding the industry average, we will collect here all the banks. Average of all banks. And if we find all banks, or the average of them is 9, which is actually 9 to 1, then in this case, the earning to the price to the earning is 9 to 1, and this bank 10 to 1. This bank has high potential. This is the conclusion, growth in the future. This is the conclusion we have to do, because now it exceeds the industry average. I wanted to take this data and this concept and apply it to the data given to us for the data given to us in the class, for this class. So if you look here, for example, this is the data which we given. If you look at it, now I take only 4 banks as industry average. I take CIMB, Hong Leong, Malaysian Bank, and Public Bank. If the industry average, if you want to calculate, I can take the average of those banks, which is this one plus this one plus this one, as I explained it to class. So what I did is actually I just make some adjustment to the data and I erase tiers, and I take the industry average of the 4 banks, and then I decreased each bank to see whether it's higher or lower from the average of the industry. This is the average of the industry. And they continued like this, and they continued like this, and they continued like this actually. And this is what I reached to. You can just do it like me. I did it before, and now I'm just retrieving. So as you can see, if this is the industry average, and this is the First Bank CIMB, this is CIMB. Now CIMB is actually less than the industry average. And 2006, 2007, almost in all the years except for 2008 and for 2020, 10 and 11. And therefore, they are not actually, the PE is not exceeding the market, and CIMB doesn't have a potential more than the market. And therefore, and this is what we are saying, so actually, it doesn't have potential more than the market, but you can find another banks if you are interested. For example, Hong Leong. Hong Leong is very, very high. It has higher potential, and it's more than the industry average by 22, by 49, by 65, even by 8 here in 2018. This is very aggressive bank. You can also graph these ones if you like. You can do so many things on this work. You can graph it like this one. I would graph it like this one if you like, and you can see the picture more than that. This is for the VAR and for the PE ratio. And the PE ratio, I want you to understand that from this perspective, that if the PE ratio of a bank exceed industry average, it has a potential growth more than the industry, and people are willing actually to pay more. If not, then there is then it's people are not willing to pay more than what is the actual price or the actual earning now going on. So let me now go to the so this is more explanation. If the ratio is managerial performance and market expectations, this is what I want to tell you. Market expectation by whom? Actually, market expectations by the investors. If the BA ratio is higher than the average market expectation, then the bank have higher than average performance in the future. This is what we are trying to do, and we didn't find it for CIMB. We found it actually for Hong Leong. Now, let me go to the VAR. The VAR is another issue. Value at risk. Let me give you this. This is, you know, just take Bank X balance sheet. This is a typical, you know, bank sheet, balance sheet for a bank. So this is dollars here. We take it from here, from here, from here, and we take all this money actually, and we invest in what? We invest all of this money. We invest it and we bring it here to loans. And whatever is left from the loans, actually we go and invest it in investments. Now, this investment could be commodities, could be derivatives, could be shares, could be bonds. It's the trading. It's the trading which we do with these things. Now, this trading actually is subject to fluctuations in the market. It's not the loans. The loans, we are only worry about credit risk, which means people will not pay us. But here, we are actually worried about what we call price risk. The price risk is our concern, which is the fluctuation of our risk. And it looks like this. So we can make it through a normal distribution, and we have to take a long time to see the price, how does it move all over this time, and plot it in this distribution and get the mean and the normal and the standard deviation. And we can make some expectations using probabilities, using the normal distribution of the expected losses in the future. This is what the VAR does. So this is more explanation of the VAR, and they can make expectations for 1 day in the future, 2 days in the future, 10 days in the future. but I have to have long period of time before to calculate the fluctuation of the price during the last 2 years, 3 years, so I can make some expectations in the future. And this, we call it the standard deviation. So if you take this example, using the data downloaded from Aecon data stream, which we have it, for the last year for CIMB, share price and we actually assuming that you are investing around 1 million ringgit and the share price of CIMB. So we want to see what is the expected losses of the worst scenario. So this is the data again. The way to do it is actually to, if you look at the data, this is the VAR of SEM. So I take, actually I have data from 1, 2, and we can do it for 2 years, calculate for 2 years, but actually we are calculating only for the price fluctuation from for 2021. So to do that, you have to calculate the VAR. It's a simple ratio. It's a simple calculation. You have to put the position. You have to put the position, which means how much you are investing. In this case, we are investing 1 million according to the problem. We have to put the standard deviation, which we call it expected volatility. Expected volatility. Between two brackets, you can put it standard deviation. How can I get the standard deviation? I can get it from the standard deviation of the price, how much it moves. So I can take this. Actually, this is the standard deviation, which is this one. Sample. And I can highlight the price all this time until here. I already have it. I'm just calculating it for you until here, until the period which I take it. Then I just close the bracket and calculate, and I found it to be 222. So this is actually, if you look at it here, it is the standard deviation of the data given. Then I have to calculate the period. So I want to see how much expectation of how much losses I will have in the next 2 weeks, which is 10 business trading days. Exclude the weekends. So the time is 10 days. And then you have to get something called the confidence, how much confidence you want in your decision. Say the confidence level, make it something like, because we have 90%, 95%, 99%, we can use, let me get the 99. And then I have to calculate the, what we call the z-value based on this one, or on 99. So what we do, I want to get what is the 99 under the normal distribution using the Z. So I use norm, and I take this one. And I bought the 99, and I close the brackets. It is 2.33, almost 2.33, which we get it always. Now we want to calculate the VAR. So the VAR is actually, as you can see here, the VAR is what? This is the VAR is the position times the adverse volatility, which is the z-value. This is the z-value times the standard deviation. Z-value times the standard deviation. Okay? And then you multiply by the square root of the time. We have 10 days. Adjusted times mean, in this case, if we have 10 days, we can have 10 days over 252. Now let me go to my file again. So the VAR is actually, we agreed that it is the position, fine, times the standard deviation, fine, times the z-value, which is this one, times the square root SQRT, this guy, of 10 days, which is this one actually, 10 days, over 252 days. What is the 250 days? It's the business days, the business trading days during the year of the extrude. And you will find this to be 103. Now 103 is actually, this is, if you want to look at it, this is how much you can lose in 10 days. If you take 99% confidence. How much I will lose in 1 day? I can change this to 1 day. $32,000. Under, do you want to change the confidence level? You can change it. It will be less. You can, so you can play with the position. You can play with the time. If you want it for 5 days, it's this one. If you wanted, this is out of the million. So you can just play with this. Let's me go back to the 99 and let's make this 10, and you will find that 2 by 103. If I take you back to the problem, which I already solved it for you, you can look at it. This is the 103 with the 10 days. You can calculate it for 5 days. I get this one. 1 day, you can calculate it for this one. Now, this is just roughly how we do it, assuming that we take data for 1 year for CIMB. Let me go here. Actually, if you look what we are trying to, if you want to understand what you are doing here, we are trying to get this area. If this is the mean is here. I am trying to get the losses, which means from this area to here. Assuming this is 99%. So the move of the mean from this area to here, it's 103 using 99%. 103,000 using this data. That's all. I want you to look at this, and I hope it is clear. But this is how the VAR works. So the VAR is actually this area from here to here. If you want more explanation about it, please look at this slide, and it will tell you and explain that the VAR is this area. Thank you very much, and have a good day, and I hope you enjoy this. Bye-bye, and see you later.